Hey everyone, Tim Taylor here with Electric Distribution Academy. One question I've gotten in the past is, why can solar PV create a voltage rise on distribution systems? So I thought I'd put together a quick video to explain that concept for you. So to illustrate this concept of voltage drop as well as voltage rise, I'll provide this very simple distribution feeder here, starting with the transmission system over here, the bulk power system, going down in voltage through a distribution substation, and going through the feeder circuit breaker and out onto the distribution feeder itself. And let's say, for example, that at the end we put a load. A load could be a neighborhood or it could be a shopping center, any type of electrical load that draws current. And this I is the abbreviation for current. In reality, the load is distributed all along the feeder, but in this simple example, we'll just put it at the end of the feeder here. And this load current has to pass through impedance in the feeder, and most often it's conductor impedance. There can also be a transformer or a regulator that would also contain impedance, but in this simple example, we will just assume that there is conductor impedance. And impedance is made up of two components, a resistive component and a reactive component. And it is this load current that is passing through the resistive and reactive components that creates a voltage drop. And with a voltage drop, the voltage is higher at this end of the feeder, and it's lower at this end of the feeder, assuming that we have a radial feeder. So if we look at another example here, and in this example, we'll take away our load and we will only have a solar PV plant located at the end of the feeder. And let's assume that that solar PV plant is creating generation, and therefore we have PV current that is flowing from the PV plant back through the distribution substation transformer to loads that are on other locations in the transmission system. So it is this PV current flowing through that same resistive and reactive component that we have a voltage drop that is now going in this direction. So the PV current flowing back to the substation is creating the voltage drop in this direction. However, another way to look at that is to call this a voltage rise. So we can see that the voltage at the solar PV plant is higher than it is back at the substation. Instead of thinking this as a voltage drop in this direction, we can think of it as a voltage rise going towards the end of the feeder. I hope this was useful for you, and for more information, go to either heatspring.com or to electricdistribution.net. Thanks for watching.